We're going to look at how we can use MATLAB to determine if a series is convergent or divergent, and if it does happen to converge and a sum exists for it, sometimes MATLAB can find the sums of those, right? So a really couple basic examples, two of which we probably know are going to converge, and then the last one's going to diverge, and I just wanted to show what happens so you could show that it diverges. So we have this 1 over n to the 4th. So what I'm going to do is I'm going to make a symbolic variable. So I'm going to say sims of a sub n and a sub n is going to be the sequence that comprises n. Okay? So next thing I'm going to do is I'm going to define a sub n to be 1 over n to the 4th. Okay, so we have a sub n equals 1 over n to the 4th. And then I'm going to use this function sim sum. So sym sum, and I'm going to say a sub n, and n is going to go from the lower bound, which is 1 in this case, and it's going to go to infinity. Okay. Now I'm just going to run this at first, and then I'll go ahead and assign it. All right. So let me suppress this, and I'll run it. Right. And there it goes. It gives us the sum of pi to the 4th over 90. Okay. Now I'm just going to call this sum1. All right. So sum1, not some person, but some number 1. And I'm going to suppress that, and I'm going to do fprintf. And I'm going to say the sum of series 1 is %s /n, and then I'm going to call sum1. All right, so if I run this one more time, it'll come up with a nice formatted way. Okay, so the sum of the series 1 is this. Okay, so a second example, we have pi over n squared plus n. All right, so what I'm going to do now is I'm going to define another symbolic variable. I'm just going to call it b sub n. And I'm going to say that b sub n is going to be equal to pi divided by the quantity of n squared plus n. And then I'm going to use sum2, and that's going to be equal to sim sum of b sub n, n as n goes from 1 to infinity, right? And then I'm just going to copy this line right here. And I'm just going to say series 2, and I'm going to call it sum2. All right. And if I run this, it should give us the sum of series 1 and then the sum of series 2. Okay, so sum of series 1, still pi over 90. Sum of this series, the pi over n squared plus n, is going to be pi. Right? Now, we know that 1 over n is a divergent series. It's the harmonic series. All right, so I'm going to define one last symbolic variable. I'm going to call it c sub n. Right? And then I'm just going to go ahead. Let me copy and paste this just for brevity. I'm going to call this c sub n, and I'm just going to say 1 over n, and I'm going to call this sum3, and I'm going to call this c sub n now. So I'm just changing the parameters of the c sub n. All right, now if I run this, we know that this should be divergent, all right, which means that it shouldn't add up to a specific number. All right, so if I run this, and I'm going to have to run it again. I forgot to unsuppress it. So we're just looking and seeing what the sum does this time. All right. And notice that it gives you an infinity for the sum. All right. So that means it's divergent. Okay. So what you would write is you would say fprintf, and you would say series 3 diverges since the sum is infinity. Okay. And then you could do a /n just so you can go to the next line. Now notice I'm not calling anything. Okay, so there's no %s in here. So if I run this one last time, there we go. That's our output, really nicely formatted. Okay, so that's how we can use MATLAB to determine the sum of some of the series. Okay, no pun intended. MATLAB can't always find a precise sum for every series. Okay, however, this very first one, 1 over n to the 4th, That's a really tough one to figure out by hand what the sum of the series is going to be. And fortunately, MATLAB can find that for us.